So there's a few things to note in this exercise. First thing we're doing is obviously drawing the curly arrows. So that means we have to have an understanding of where the nucleophile is and where the electrophile will be. So for the nucleophile, remember that's something which is negatively charged, and what we're going to do is draw our arrow from the high electron density nucleophile, which is here, through to the low electron density electrophile. So this is our nucleophile, we just call it Nu minus. This is our electrophile, we call it E plus. Arrows go from high electron density to low electron density, forming a bond between our sulfur and our hydrogen, giving us our product. In the second example, we're looking at a general nucleophile, so we're just calling it Nu minus. So this is where our arrow will start, from the high electron density. But what we have to do in this example is decide where is the electrophile, and it's at this position here, so we can put this one here as delta plus. That position there is slightly positive because the oxygen being electron withdrawing is slightly negative. So this bond is what we call polarized. There'll be less electron density here, more electron density here. So again, let's draw our arrow from the high electron density through to the low electron density area. Break that bond. Remember, carbon obviously can only have 4 bonds, so if we're forming a bond to this position, we have to break a bond. That means that our nucleophile is now attached to the carbon. These two substituents are the same as the ones we had here. We've pushed the electrons up onto here, so we've now got a single bond, and because that has gained electrons, it's minus. So remember, when we're doing these sorts of reactions, we have to balance both the atoms and the charge. So note in this example we had a minus and a plus, so they neutralise. So on this side it's going to be neutral. Here we got a minus on the left hand side of the equation, so we need to have a minus here on the right hand side, and it's up on this oxygen. The only other thing I wanted to note here is the type of arrows that we're using. So note we are using these arrows here, what we call double-headed arrows, and that's because we're dealing with the movement of charged species. So these we use where we've got charged species, so for heterolytic reactions. In some cases, not specifically in my course, but later on in your program, you will see these single-headed arrows. That's where we're just moving one electron, so for instance with free radicals, and these are homolytic. So the key points here, we've gone from high electron density to low electron density, and we've used these double-headed arrows because they're heterolytic. We've made sure we've balanced both the atoms and the charge on the left and on the right.